Oh, you guys are waiting for the camera to start. I understand. Yeah, Giselle, you let us know.
Got it.
Because everyone's holding back right now. They want to, they don't want to show off their knowledge here. Fundamental theorem of calculus. What is the fundamental theorem of calculus, Jasmine?
The final value equals the initial rate.
The final value equals the initial value. Plus
how much the function changes by.
Plus the total change. Now, when is this true? All the time. Remember that the problems we looked at yesterday, and Rambir and Jennifer and Kimberly, you'll get it in the notes. We looked at like this example of every time you answer a question correctly now, you get 75 cents.
Oh yeah.
What's the 75 cents?
Oh, correct answer.
Is that the initial? Is that the final? Is that the change?
It's a change.
It's basically the 75 cents is like the rate of change. 75 cents is your rate of change. The total change is like how much you earned, right? If I answered 10 questions correctly at 75 cents per question, the total change, you would say, oh, it's 10 times the 0.75. Another way to say that it's how much you've accumulated. What was the initial value? What did the initial value represent?
What you walked in with.
It's what I walked in the door with, right? How much I had in my pocket. So initial value, what I started with, and the final value?
When you walked out.
What I walked out with, what I ended with. And that was the fundamental theorem of calculus. Love it. And so that's the words, my verbal folks, if you remember final equals initial plus total change, lock it down. And I can see for some of you that really worked well. For others, you like formulas. You can get tattoos of formulas. What's the formula?
F.
Yeah, F.
B. I don't know.
F of B
Equals F
Equals
of A
equals F of A
plus the area.
plus the area. That's that
definite
total
integral.
change. That's your definite integral.
A to B. F of
function.
X.
It's
The
very good.
derivative.
F prime
D of X.
F prime of X dx. F is your function, F prime is the rate of change. It's how fast the function changes. The definite integral is how much the function changes. Are we okay?
Yeah.
Remember the verbal piece, or remember the formula piece, David. Either way, you're going to be set up for success. Are we good? All right, so let's go back in time, shall we? For the next 10 minutes or so, I want to do a deep study of this concept of average. So we're going to pretend you're going to jump in the TARDIS with me and go back in time to when I used to teach elementary school. I did. For 2 years, I taught kindergarten. Man, those kids did really well in the AP exam, let me tell you. Okay. I want you to go back to about 3rd grade. I don't want you to act like 3rd graders. I want you to go back to 3rd grade. And let me read this first question to you, because you're in 3rd grade, you can't read yet. On Monday, my brother Jeff ate 23 M&Ms. On Tuesday, he ate 79. On Wednesday, 32. On Thursday, 122. On average, how many M&Ms did he eat each day? Show the work that supports your answer. I want to know how much, on average, how many M&Ms does he eat every single day? My 3rd graders, what are you going to do? Let's get some hands on this. How are you going to figure this out? I know you're not actually in 3rd grade. David, what are you going to do?
Add up all the numbers and divide it by the amount of days.
You're going to add up all the numbers and divide it by the number of days. Why are you going to add up all the numbers?
This is the average he ate per day.
And how do we find average? You're right, you add up all the numbers, but why? Why do we add up all the numbers? Why do you add up all the numbers, Marvin? What you want is the total number of M&Ms. And David, I heard you say you're going to divide by 4. Why divide by 4?
Because it's the amount of days he spent eating the M&Ms.
Okay, number of days. Third graders, we've got this under control. I know you're not actually third graders. But this idea that got introduced in third grade is all that you need for everything we're going to do for the rest of today. So show me what you can do with the elementary school problem and the middle school problem. I'm looking for 3 things. I want the right number, I want the right units, and I want a sentence. We'll check in a little bit. Whoa. And since you're in third grade and maybe your math skills aren't so strong yet, if you need your calculator, feel free to use your calculator.
You're right. You're struggling.
Don't overthink this.
48.
No.
No.
What? What's 62?
Ron Beer was absent yesterday. You'll have to forgive him. He's still in India time. Ron Beer, have you figured out that it's not 48 yet?
No, I was kidding. It's 64.
Okay, good. Just check.
What?
I want to see the number, the units, and the sentence. All right, third graders, the perfect answer to the elementary school problem, if the right number is 64, you're going to get a point for the number. You're going to get a point for the units. The units are going to be 64 M&Ms each day. You're going to get a point for the sentence. The sentence, I need to see the word average. You need to work that word average in there. On average, Jeff ate 64 M&Ms each day, but make sure you tell me for 4 days. I need to know the number, I need to know the units, and on what interval this is good for. That's the perfect answer for me. That's going to be where the 3 points are coming from. Now, I'm curious, how many times did he actually eat 64 M&Ms?
No.
How many days did he actually eat 64 M&Ms?
2.
How many, let me ask, on how many days did he eat exactly 64 M&Ms?
None.
There are no days where he eats exactly 64. Some days above the average, some days below the average. I know this, you're like, I've known this forever. Good, these are all the ideas that we need for the rest of what we're going to do today in calc. All right, so keep going. Show me what you can do with this middle school example. If you think you get the middle school example, call me over, I'll give you a clean bill of health and you move on to the calculus example. The fastest progression from 3rd grade to 12th grade ever. Giselle's everything working out with the camera? Yes, sir.
Oh, I never was there.
Did you get it? Oh.
So would you put point on that?
I think you added the numbers wrong. It should be exactly 64. Once you think you get the second one, call me over.
Wait. Oh, okay.
Yes, sir. What you got?
Wait.
So you get
Did
the number.
you edit all that?
Yeah.
And what did you get? And then you added all the hours? What'd you get? 16?
16 hours.
Wait, how can it be 16 hours? Wouldn't it be 5 plus 4?
What did you say?
Oh, okay. Okay, yeah. Wait, 15 hours. Oh, okay, yeah, 16 hours. And then you divided that? But that's 2. Shouldn't we be getting the same answer? 64?
Either way.
Oh, no. It just changed, right? So, what? On average, how many? So, he ate 2 point something M&Ms.
All right, if I could interrupt all the good stuff that's happening just for a minute. What's wrong with the thinking that's up here right now? The kid that was really good at average in 3rd grade is now in the middle school problem, and they see this problem and they say, oh, 15 M&Ms per hour, 12 M&Ms per hour, no M&Ms for an hour, 8 M&Ms for an hour, divide by 4 and I'm done. Jennifer, what's wrong?
It's like for the first one it's 4 hours and now he's counting 1.
Right, this 15 M&Ms is his rate for 4 hours. So I've got to take the 15 times 4. We're okay with that, right? And then?
For 12 it's 5 hours?
It's 12 M&Ms per hour for 5 hours. The 0 M&Ms for 1 hour, and then the 8 M&Ms for what, 6 hours?
Yeah.
And that's going to give you the total number of M&Ms divided by 4. Adriana, what don't you like now?
You need to add up all of the hours. So it will be 4 plus 5 plus
Right,
1.
it's the 4 hours in the beginning, plus the 5 hours, plus the hour that he took a break to go throw up, plus the 6 hours at the end. You're still dividing by, it's the total number of M&Ms divided by the number of hours. That's still how we're going to find our average. And what I saw walking around the room, almost everybody had 10.5. Okay, Jose, what's the perfect sentence?
On average,
On average,
Jeff ate
Jeff ate.
from 0 to 16 hours,
Yep.
10.5 M&M.
Okay, I'm going to write it as 10.5 M&Ms each hour. Each hour for 16 hours. Your perfect sentence. On average, the number, the units, the time interval, perfect. Lock it down. All right, trust the instincts. It's time for the calculus problem. Finally. The graph at the right represents the rate at which Jeff is eating M&Ms measured in hundreds of M&Ms per hour over the course of a 12-hour period of time. Determine the average rate at which Jeff consumed M&Ms during this 12-hour period of time. Have a strategy conversation. What are you gonna do? Don't talk to me, talk to your neighbor. What are you gonna do about this? I want the average number of M&Ms. Trust the instincts.
Is your divide that by the 12-hour period?
So we know it's from 0 to 12,
The
right?
rate times time.
So that's going to be the...
How many M&Ms?
Can we just get the equation from the graph?
Oh yeah.
Yeah, I was gonna say because I'm like,
But what area? Like, does it end here? Or does it end at the x-axis? Further, does it end here? Or at the x-axis? For the area? Oh, all the way to, okay. What's FP though? What's the final? Is it 14?
Good.
Mr.
Wednesday.
D,
Yep.
for their FP, would we use 14? Since that's the final at 12.
And here's where you need to be careful, because it sounds to me like you're trying to do like a fundamental theorem of calculus question. And maybe it's not a fundamental theorem of calculus question. Okay, from walking around, it seems like everybody's figured out that this is an area problem. Okay. To get the total number of M&Ms, because this function here, J of t, I want to think about this as how fast he eats M&Ms. So how fast he eats M&Ms. If I want to know how many M&Ms, it's going to be a definite integral from 0 to 12, J of t dt, and I'm going to divide it by 12. Because that's how the definite integral works. If J of t is a rate, it's how fast, then the definite integral is how much, how many M&Ms. And walking around, I saw a lot of folks that said, I want to go from 0 to 12. Great. Go from 0 to 12, you need the area. So good, clever thinking here is like break this up into regions. David, are you okay?
No, I can't see because of my projector.
Okay, sorry. So I saw some folks that said, I want to divide it up here, 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 and here, and go with rectangle, 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 triangle, triangle, 5 regions. That's good, that works. Better way to do it? Two trapezoids, right? Take advantage of your trapezoids. So if you do that, there's 1, there's 2, there's 3. And if all goes well, I had my solutions somewhere. They're gone. What is this? 3 times, what is that, 9? A half of 9 plus, that looks like 2 times 4, a half of 2 plus, what is that? Is that 14? Times 5 divided by 12. I think that's 89 over 12.
Yes.
Which?
7.4.
7.416?
Yes.
How many guys honestly hit 7.416? Okay. That is good. That's the right number. I want the perfect answer. I want the sentence. Go get me the sentence. Get me that sentence. Oh, so close, but no.
Is this one or this week? Do we do it with this week? So like 8 M&Ms?
No, don't round.
Oh, okay.
Don't round.
No.
There are such a thing. There is such a thing as like a decimal part. Nice.
What did you put for your hundreds of M&Ms?
I don't know if you can read it.
What you got for me?
To consume instead of average rate of the number.
Okay.
Over the 12 hours.
Popular wrong sentence. On average, Jeff ate 7.416 M&Ms each hour. Each hour for 12 hours. I saw that in at least 8 papers. What's wrong with that? What's wrong with this? There's something wrong. On average, Jeff ate 7.416 M&Ms each hour for 12 hours, knowing me what's wrong.
It's not each hour, it's for the whole 12 hours?
Each hour, you're saying you don't like the each hour part? But actually that is a correct interpretation for average. What you're saying is on average, every single hour, he would eat 7.416 every single hour. That's not the problem. Eunice, do you see the problem?
Is it the rate?
What's wrong with the rate?
You want to say on average, maybe put at a rate of 7.416?
On average, Jeff ate 7. Okay, you could say at a rate of, but it would still be wrong. Go back and read this problem one more time. There's something that you guys are missing. Hold on, Marvin and Nora, I see you. There's something really, really important. It's subtle, but it's lethal. Daisy, do you see it?
The answer's supposed to be in hundreds?
That 7.416 represents hundreds of M&Ms. So it's not that he ate 7.416 M&Ms, it's 7.416 hundred M&Ms. Don't worry, my brother is okay. He did not go into a diabetic coma because this is just fiction. He didn't eat 7.416 hundred M&Ms each hour.
Your brother's name is Jeff.
My brother's name is Jeff. Yes, welcome to the DeRocher family. Big picture, is everybody okay? We're in a good place? All right, good. So let's do some real calculus now. You guys are in a good place. Let's push on. I've got a new formula for you. I love having a new formula. Lots of practice coming your way. We'll get you to use the calculator. And then you'll go into the weekend with some homework that's all calculator active. Yes! Yes! We all love the homework that's calculator active. Okay. New formula coming your way. For a continuous function f, the average value of a function is going to be found this way. So draw yourself a function. Make yourself some pretty function. Doesn't matter what it is, but it should be continuous. I've got a function on the interval a to b. I want the average value of the function. I want the average of the y value. So the y value here, the y value here, here. I want the average of all those y values. All infinitely many of them between a and b. The way that we're going to find the average, just like the M&Ms, we're going to find the integral of f of x from a to b with respect to x. So we're going to find area. And we're going to divide by the length of the interval, b minus a. Just like with that last M&M example. J of t was the rate that you were eating M&Ms. By finding the area, you found the total number of M&Ms, and then we divided by how long it took to eat the M&Ms. Exact same idea. Find the definite integral from a to b, divide by the length of the interval, that's the formula. Everybody okay? Okay, some textbooks like to write the average value formula this way. Same thing? How many guys are convinced that the same? They're exactly the same. Okay. Jonathan, why are they the same?
Because if you multiply it, it's still going to be that over 3 minus
Okay, if I look at this expression over here, the definite integral divided by b minus a, if this number was 5, to divide the area by 5, it's the same thing as saying 1/5 the area. So memorize it this way. Memorize it this way, it doesn't matter to me. Everybody good? All right, so let's do this. These are going to go nice and quick. For the function shown to the right, determine the average value for the function on the interval -3 to 6. Take 1 minute on your own, show me what you can do. The average of that function from -3 to 6. Normally on the free response section, you get 1 point just for the setup. Average value. A is -3, B is going to be 6. Just did a quick stroll and saw a whole lot of folks have set up on the paper. It's going to be the definite integral from -3 to 6, divide by 6 minus -3. How many guys have that as your setup? Okay, good number, folks. We're moving in a good direction. Now, if anybody is interested in finishing this one off with me, I'll do that. Otherwise, go from here. Anybody finishing this one with me? Okay, a couple of folks. All right. So, Noemi, how are you gonna move forward with this?
Find the area and the function.
You want to find the area from where to where?
from -3 to 6.
Okay, so I'm going to draw a vertical line over here at x equals -3. I'm going to draw the vertical line over here at x equals 6. And how am I going to find the definite integral from -3 to 6? I said definite integral, but really what I'm asking you to do is find the area. So go find the area. So if I'm going to find the area, got a triangle, got a semicircle, got a triangle. Edgar, what are the formulas that we need here?
1/2 base times height,
Area of a triangle is a half base times height.
pi r squared.
Okay, we're going to need pi r squared. You're close. I like
Oh.
it. I don't love it.
1/2 times pi r squared.
Okay, 1/2 pi r squared. And okay. Integral from -3 to 6. That first triangle is going to be a half. The base is what, 3? Height's going to be 6. For the semicircle, it's going to be a half of pi. My radius is 2 squared. That last triangle should be a half. The base is 2. The height is 6. And I'm going to divide the whole thing by 9. Really, the big calculus work comes in with the initial setup, knowing that you need to do an area calculation, and then after this, it's just all the basic math stuff. And Jose, what's the biggest mistake that I'm afraid somebody's going to make? You won't make it. But if someone's going to make a mistake, what's the most likely mistake?
That's they're going to add at the bottom as part.
Right, they're going to forget that this semicircle region down here actually is a negative area, so you need to do this minus that area plus that area. So finish it off. 3 times 6 is 18, cut it in half is 9. 2 squared is 4, 4 pi, cut that in half, 2 pi. 6 times 2 is 12, cut that in half is 6. Divided by 9, I think the answer is 15 minus 2 pi over 9. How many guys have 15 minus 2 pi over 9? 1, 2, 3. Whole bunch. We're in a good place. Really, for the next 25 minutes, we're just going to keep taking this idea of average value and putting it in a new way, pushing a little bit more. So these next two are calculator active. And Ron Beer, how do you feel about driving my laptop again? Okay, so if you go back. Okay, model problem number 2. I want you to get a thought partner with this. For the function f of x equals -3x squared plus 6x plus 1, find the average value for the portion of the graph in the first quadrant. For number 2? Not the right answer. Not done.
Can we just draw it in the box now? Just from the intersection?
Where's your calculator?
Just charging. It died just last period.
I mean, there was a reason for that.
No, it was fully charged.
Where did you get your
What do you
battery?
mean
Oh,
And
okay.
then I gave it to my computer. It's already. I'm on Amazon.
Oh, you find F prime, so
If
negative
you find one,
6.
but it's not. I don't think it's a bad
That's six.
We've had them for a long time,
And
since
then
8th grade.
It's the battery.
Since 8th grade.
Mine doesn't.
And do we divide by
I can't use a regular
2.15?
phone. That's not. It's not able to
All
charge.
of it.
So I'm pretty sure
Yeah,
it's a
right?
new battery.
Oh, for it to last
It's
longer.
just
Yeah.
$5.
But you have to find
Get a
it.
battery.
No, but
Yeah, 'cause it's
it's
prime.
messed up for mine. Somebody messed up.
You better not take care of yourself. I mean, I can't talk.
Yeah, Yeah, because I lost my pens and I need to borrow it, right? I need to take care of my stuff.
Can't break habit. I got 6
What'd you say, Henry? Yeah, you got a computer.
I got negative 3.45.
Look at the college. Oh my goodness. So. Yeah,
Why do you want this?
It's not a sign. Oh, okay. Yeah, I did it wrong. My bad.
That's not the answer, Robbie. No, it's like you're almost there. You have to divide.
All right, I was spending some quality time back there with the TI-84 crowd. Okay, nobody fell for it. You graphed f of x. I wanted the average value in the first quadrant. The tricky part here, Jennifer Ortega, what was the tricky part? Where was I trying to mess you guys up?
I didn't know how to like find like where the stops.
Right, because I said in the first quadrant. So we're going to have to say from like starting over here at 0 until where? Until it hits the x-axis. That's going to be the part where we stop being in the first quadrant. Now, it looks like what Rombier did is he said he found it, and you got like 2.155, Rombier? Maybe some other folks have 2.154? And then I bet a lot of you said, let me go from 0 to 2.155 f of x dx and divide by 2.155. Did anybody actually store that value in the calculator?
Oh, we could rename it E.
Storing it would be good. And since it's been a while, let's take a minute and go through and do this. So Rombier, pull the graph back up. Okay. So you've got the root. So remember, you click on the root. I think you need to do a double click. And then var. Come over to var. And then call it A. And then hit enter. Oh, bummer. They already used A last period, so double click, call it something else. But for everybody else, you should be able to do it fine.
Call it E.
No, you erased it.
Okay.
There you go.
Double click, while it's highlighted, var. What's going
You
on?
only click it once,
That's, okay, so you're saying click it once?
maybe.
What is going on? Okay, Ron, here we go. Alright, let's see how the big boys do this. Okay,
Oh.
while it's highlighted, var, there you go. Store var, A. Okay, so it's a single click, not a double click. My apologies.
2.014.
Okay, but if you're gonna call it A or B or E because you're Edgar, you better make sure you're telling me what the letter is. You're gonna go from 0 to A, divide by A minus 0. So Ranbir, if you switch over to the calculate part. What'd you get for your decimal? So Ranbir, if you could just retype your integral. Ranbir, if you could retype the integral with the A. With the A. And even better, we're going to do this in one step. So get out that 2.155, type in A. At the end of the definite integral, hit the divide sign. Divide by A. Hold on, David. Okay. What I love with the Inspire and the 84 folks, unfortunately it doesn't work as nicely for you guys, is that exactly what you wanted to have typed in. The definite integral divided by A, yes, perfect. You're better off doing it in one step, it's going to be cleaner. Okay. All right, show me what you can do at number 3. Number 3, you're actually going to do this one twice. First time I want you to do this calculator active. then without the calculator. Once you've got it, let me know and I'll move you on to the more challenging problems. What's that, David? Because you didn't do the store feature. You used 2.154.
Oh,
But the real root is
Put
2.154.
first, right?
So what's happening is you're rounding.
No? Yeah, because I remember yesterday I did that. I did from negative to positive. And
Pi
it
before
was
plus pi before equals 2.
oh, you have to put the negative in front.
Get all the ones.
So now you can add or
Mr. D?
Yes, sir.
For this one, is this like the one from yesterday where we had to put the negative sign if we put negative, if we put from negative?
Okay, so the way it's set up, you're integrating from A to B, and then you're dividing by B minus A. A is negative pi over 4. B is positive pi over 4. So it would make a difference. You're integrating from negative pi over 4 to pi over 4, sine of x dx. Divide by pi over 4. Yeah.
Whoa.
Where's your calculator?
I'm gonna use the battery to see if
All the rest of these problems are calculator active. Jose, do me a favor. Can you get my calculator out of my bag? Once you've got the answer to number 3 and you can tell me what you would do without your calculator, I'll move you on to the more harder problems.
Oh, I didn't rename it. Wait, I don't have.
So, okay, actually, I'm glad that I saw this.
I get the golden.
We got a little bit of a problem here.
What is it, 0?
Yeah, it's still bad. Okay, so you're over here on the side. You're doing all your graphics. Okay, so let's do menu. Settings over here. Okay, so you're saying you can come up with the answer without the calculator.
Is it 0? So it is.
It's a power function.
Your setup is perfect. Type it in correctly. Get a key. 100% right.
Oh, just by looking at the graph.
So the final answer is 0.
Oh,
What do you have the calculator?
because the areas,
It's not about the oscillating at the end. It's about the fact that the sine function, you pass through the origin, but it's an odd function, and so you're going from negative pi over 4 to pi over 4. How much area is it? 0 because they're going to cancel make a negative. Alright, good. So move on to number 4. Okay, friends over here, did we get 0? Why?
because from 0 to from negative pi over 4 to 0, the area is negative.
Yep.
And from 0 to pi over 4, the same area is positive.
It's the exact same area, but now it's a positive instead.
What do you mean?
So what if this was the cosine function? Would it still work?
I've never seen them do it.
Would you still get 0?
Unless it's like zero, and then
Yeah, feel free to test
figure
it
it
out.
out. You already hear it? It's an odd function, so
Yeah, because
It wouldn't
they
be
can't
this
switch
cosine,
over.
it's an odd function. This works because you have an odd function. Good, try number 4. Okay, friends over here, how are we doing? We get 0? Okay, it's why are we getting 0?
Today?
it's an odd function.
What's on?
They're gonna cancel out. Good. So even if you didn't get the calculator for this problem, you should still be able to do it because you're gonna think about what do I know in the graph? I know what's happening with the graph. I know oscillating is what happens at the ends. But if I'm only looking from negative pi over 4 to pi over 4, I don't care about the oscillation. Okay. Show me where you can do number 4. Zero, moving on to number 4. Alright, 8 on number 4. Word problem with how that number is that and I want to know the interval, right? It's an average that works for a particular amount of time. You know, I'll like over here. Are they explaining a little bit of your answer? Alright, around here probably at this point, I want to come back. I'll join the friends, that would be a good one.
There's one alongside both of those.
Mr. Jerome,
Yes.
Check your range, I think. I don't graph it. I just put it into calculator. What'd you do? 165.
Abraham gives you an iron. But it's not the best. It's not the best one. Did you use the table for stuff for a second? There's
Did it
something.
show up on your graph?
It's super picky. Super picky. Super picky.
Oh, so if you put v of x,
Right. If your variable is t, everything's in terms of t, it's going to be t on the x. The good news is the college board's going to be very forgiving about that. But I'm not saying about the college. Because there might be people out there that are picky about it. So, here's my question. If I'm scoring this, I'm going to say, okay, Anthony clearly understands the setup for average. Check. Anthony's got the number. Check. Now I'm looking for the sequence that explains it. Right, so on average, fill in the blank. Right, in terms of a calculator, it has to be X. Are you on a break? What's going on? No. Oh, okay, one thing, so I really want you to get used to doing all the calculations. Kind of like when you were doing it on the calculator, you found the area, the answer, now let me divide, you would then
Yeah, you have
right.
What the area is.
Doing it that way, if I go back up,
studied, and I'm still getting the house.
divide by 6,
But the values are
then
still
the
zero.
calculator is going to display exactly what written anyway. Right, so you just gonna see
Isn't
that.
that what you just did?
You also need to remember though, I need to see.
It's different, because like you first divide like 4
So already like marvelous.
That's the specific number.
Gets the first point, he doesn't know what else
So
to do.
it's gonna be 6 minus 0 over
You're
4.
also responsible for the test and the time that you get to use the output. Right, you can at least see a problem with this. I know the setup, I know what to do.
Over the first
Use what you got as the rate. Even if you don't come up with the right window, all the work that you're doing, they're actually happening to the right? So when you do your math on the height,
how many trapezoids?
yeah,
It tells you.
Wait, how much is it? But then,
you know how they they're all even if you haven't figured out.
oh, 3 over 2, right?
Yeah, my
So that's what we're adding by for each channel.
All right, math team, time for a quick show and tell before I push you guys a little bit more. Now, mine are in a slightly different order, but I saw just about everybody had their setup. They had integral from 0 to 6, p of t dt divided by 6. I happen to write it as 1/6 times all that. No big deal. 158.165. Everybody had the number. Thousands of dollars per month. Care greatly about that. Now in part, is it part B? Where I want the trapezoid method. Now it's been a while since we've done any of the Riemann sums. What I saw in some papers, and it was such a good idea, I saw a lot of folks that said, all right, it's been a while, I'm going to go from 0 to 6. How am I going to go from 0 to 6? I need 4 trapezoids, and they're each going to be the same width, so I'm going to make my cuts at, ooh, awkward. We're going to have to burn that video. 0, 1.5, 3, 4.5, and 6. Doing this side work is a really good idea, especially if you're feeling a little bit rusty. And then your setup, you've got the 1/6, 1/2, p of 0, p of 1.5 twice, p of 3 twice, p of 4.5 twice, p of 6 once. Multiply the whole thing by a half, and it comes out to be 157.879. How many guys had 157.879? That looks like nobody. Okay. For the trapezoid. How many guys had the setup and didn't get to the calculation part? Okay, fair enough. All right, we've got about 4 minutes left. I want to push you guys' buttons. You have 1 minute, completely on your own, no help from anybody. Problem number 5, about Jules the super cat. Yes, the squirrel. When you read, you'll know why there's a picture of a squirrel.
Oh, I see it now.
There you go.
Oh, where's the cat?
Jose.
Draw one.
Thank you. Now the fool can focus. Actually the same as taking greater. Up here, right? There's no f of x in this problem. All right, Jules' supercats flying to the rescue of a wounded squirrel. Her velocity can be determined by the function v of t equals e of t sine t meters per second. Assuming it takes her 3 seconds to reach the squirrel, determine the average acceleration. Using correct units, explain the meaning of your answer. I saw on at least 7 different papers that setup. And it's wrong. Why? Oh, why is this wrong, Daisy?
Asking for the acceleration, not the velocity.
What's this going to tell you?
Velocity.
This is going to tell you average velocity. If you're not paying careful enough attention, you're going to use your newfound powers in absolutely the wrong way. So the question then is, where the heck does the acceleration come from? Jasmine, where does the acceleration come from? The derivative. I need the, let's just at least set it up. I need the derivative of the velocity. So I actually want to find the derivative here. The derivative of the velocity, if the velocity is e to the t sine t, derivative rule I need here?
Product.
This is product rule. Product says take the derivative of the first, e to the t, leave sine t alone, plus e to the t, times the derivative of sine t, which is cosine. So your average acceleration is going to be the integral from 0 to 3 e to the t sine t plus e to the t cosine t dt divided by 3. I'm not worried about you typing it into the calculator and getting the right number. Okay? Homework this weekend. Good news, it's all calculator active.
Oh my God.
It's all, it looks bad, it is not bad at all. There was a lot of typing in the setup. You're gonna be fine with this, Jose. If this takes more than 40 minutes, you're probably doing something wrong. So you can, no. Yeah, you can stop, okay.